Alright, this is our circuit diagram for the hydraulic circuit for the log splitter and the chipper motor. This is for the pump, goes through here. This is a pressure relief valve. Ours is set at 300 psi. So pressure gauge goes to the first DCV, which is an open center. That means when it's in the center position, it's just going back to tank. Once the push button or lever is actuated on this side, pressure goes straight to the cylinder for the splitter, which is the extension. And when it goes to the other one, it's retraction, and also there is a meter out flow control right here. The same pressure line goes to the second DCV, which is solenoid operated with a spring return. And as you saw in the video, this has to be actuated in order for the motor to turn. It's a closed center, so when this solenoid is actuated, pressure goes to the motor, turning the motor in a forward position with the button, and you turn the motor off and put it in reverse, and there is a flow control here for reverse, which slows it down as well. And goes back to tank, and that's about it.
Okay.
Alright, here is the calculations we did for our circuit. The first one, we figured out the cylinder area. This one we solved for the maximum force output of the log splitter, which is 2,450 pounds.
That's retraction.
This is retraction size, and this one is the extension speed, which is 2.55 inches per second extension speed, and the retraction speed, you'll notice, is quite a bit more. The cylinder was going back much faster, and that is 5.21 inches per second.
All right, throughout the semester of hydraulic fluid power and controls, we've done a lot of tests with calculations for a hypothetical wood chipper. So we decided that for our final, we were going to create this hypothetical wood chipper that we've been working on. And what it consists of is a cylinder that is going to extend to actually split a piece of wood. Then it's going to retract at a faster pace than it extended. And we control that by adjusting the flow control here. That will allow for more production to get completed in a shorter time. Another feature is that it also includes this hydraulic motor, which is controlled through an electric solenoid. It has forward and reverse, and that will be attached to the chipper portion, which will allow for excess wood to be chipped into fine pieces. The forward speed is going to be faster than the retraction speed in case anything gets stuck and we have to reverse the motor to get it out. We don't want it to shoot out towards the operator. And again, that flow is controlled right here through a flow control. And here's how it works. First, we're going to extend the splitter. As you can see, the splitter is extending very slowly so that if anything happens, you have time to stop the machine before it causes any kind of damage. Once it reaches full extension, we're going to retract it to be able to load another piece of wood. As you can see, it's retracting much faster. Once it's completely retracted, you have the option of using the wood chipper. We'll start with the forward function first. If you take a look, it moves quite quickly to be able to chop wood into fine pieces. If anything gets lodged in it, you can turn it off and then reverse it. It's going to reverse at a much slower speed, allowing anything that's stuck to come out without injuring the operator. The whole system operates at about 300 psi of pressure, which is generated by a pump underneath the workbench, then controlled here by a pressure relief valve. And just to make sure that we have a check in case anything goes wrong, we know if the pressure gets too high by using this gauge.